All right, so we're going to go to Unit 13, Lesson 4, and this is very similar to the first unit where we talked about parent functions. Like um, what is this line? Is it quadratic? Is it linear? Is it exponential? Is it cubic? Is it quadratic, which means something squared, right? Plus some other stuff, right? So, what is the parent functions if I'm given a data set or a graph, right? So, or an equation, what's the parent function? All right. So, what are some things that I can like kind of evaluate to see if it's what type of function it is? First thing, and one is the rate of change. The rate of change, rate of change of x of y compared to x, right? Or y over x, right? Um, so like, or if it's a linear equation, the slope, or is the rate of change consistent? If the rate of change is consistent, it's going to be linear. If the rate of change is a factor, like it multiplies something by some other number repeatedly, then that's going to be an exponential change. Okay, that's one thing you can look at. Another thing you can look at is the shape of the graph or the shape of the numbers, right? Um, and if you see the data and you know what the shape is, then it's pretty obviously what it looks like. But you could also look at the characteristics, like the range of these things. All right, so let's go to some examples here, and you can see what I'm talking about. All right, so here is a change in x. The change in x for each one of these from each data point is it goes from -2 to -1. So from -1 minus -2 is it's a +1. Okay, from 0 to -1 it's +1. So this is +1 and this is +1. So as x changes by 1, how much does y change? Okay, well, from here to here it went to 1/4. From here to here, well, it's 0 divided by 4, which isn't a number. But then it starts going back up again, right? So this, if I were to plot this thing, right, it's never negative. It does not exist when where y is negative. Okay, so it doesn't exist down there, right? And when it's -2, it's like way up here at 16. When it's -1, it's like 4, which is like right there. When it's 0, it's here, and then it kind of mirrors itself on the other side. It's reflecting itself, if you will. So it kind of looks like that. Okay, curvy. Right. This is a parabola. Right, and you know that parabolas are derived from something that has the x value or the variable raised to the 2, because quadratic is Latin for quadratum, which means cubed or square, right? So this is x squared. So that's what this one is. Okay, so here's another one, and we can see, well, for every change it's hard to really identify good numbers, right? Because they're like out here in between integers. So it's hard to kind of see what's going on with the change in y to change in x. How about the shape? Okay, well, the shape looks kind of like it's approaching an asymptote, but I have a feeling that it's not really. But what happens? Why is this? There's nothing under y. There's nothing under y. So if I put in an x value, I will never get a negative. Not for here. Okay. This is also, if I put an x value, it could be this one, right? But these result in straight lines. So it's not that. Okay. This is an exponential, right? You remember b to the x, so I just keep doubling it. But this is getting, this would look like this if it was exponential. It would be getting bigger and bigger and bigger for each one progression of x. So it's not that one. Okay. But but it's never negative. So which one of these makes it so that I can never have a negative number? Well, the square root, right? This one right here. I can never have the square root of a negative number. That's a real number. I can have imaginary ones, but that's outside the scope of this, right? So this is what this is what the shape of every square root function of x would look like. Okay, so it might be shifted over, it might be grown up a little bit, it might be smaller, right? But it will never be negative. Okay, unless I do like a -3 or something after the radical form, and then it would shift it down here, right? But it would never go below something like that, okay, in here. Okay, so here's this one. All right, so again, this is the change in x is all +1. It's getting bigger and bigger by 1. The change in x is 2. The change in y is 2, 2, 2, and 2. I'm adding 2 to each one of these. All right, so this is going to be a linear equation where y equals x. Okay, it's all about what happens. What do I do to x to get y, right? So there might be like like 2x in front of here, right? Because for every change in y is 2 changes in x, right? But that's neither here nor there. Okay, but this x equals y. That's the parent function. Okay, here's a cubic function. Right, this one's pretty straightforward. Since this is raised to the third, it's this one. Okay, what happens to the variable? All right, so this one again changes all as a change in 1 from each one, +1. This one goes -2, then it's -2 again, but then it's +2 and then +2, right? So and initially it starts to look like it's linear, but then it turns. So it looks, something like this, but it's linear, right? And it goes this is 5, so it's a straight line, constant change, right? But then it does this. Okay, so that is an absolute value function. Okay, this is 5 away from each one of these is 2 away from each one, right? So that's an absolute value function. Okay, so here's a funny one, right? So this, if I look, I see that I'm going to have, it gets really big really fast, right? But it could be like that if it was a quadratic. But the thing about quadratics is when you square a number, like if you square a positive, you get a positive. If you square a negative, you get a positive. Okay, so when you're looking at, so this is why you always have a positive up here. That's why it always turns and it's pointing the same direction in a quadratic equation. But if you're taking something to the third, right? If you take a positive to the third, you get a positive. Right? If you take a negative to the third, you get a negative. Right? So this is where you're going to have something that looks like this. Right? It's like, or it could look like this. It could look like that too, like a chromosome, right? But what happens is, sorry, I lost my train of thought. So this gets, instead of it having it like flipped up like this for a squared function, you get the negative returns for that from this aspect right here. So this is a x cubed. Y equals x cubed. Okay. All right. So let's look at the next one. The next one, let's see, it's a change in x is all +1 still, so has y change? Well, from here to here, so it went down by a half, right? So this divided by this is a half. This divided by this is a half. This divided by this is a half. This divided by this is a half, right? So this is a 1/2 raised to the x, right? So every time I take y, in order to get y, I take x and I raise it to the 1/2. Okay, you see how I did that? That was 2, -2 divided by -4 is a half. -1 divided by -2 is a half. 0 divided by 0, but we're looking at the change in. Okay, so there is that one. All right, same concept here. All right, it's x is change in x is 1. From here to here, right? I doubled it, right? It goes, let's see, from here to here, let's see, 1/8 to 1/4. Yeah, if I multiply this by 2, I get 2/8, which is 1/4, so I doubled it. From here to here, I doubled it. From here to here, I doubled it. From here to here, I doubled it. All right, so this is 2 raised to the x. Okay, this is an absolute value function because it's a straight line, v. And then this is a y equals mx plus b. So this is a linear function of y equals x. All right. Hopefully that was pretty straightforward and a review of stuff way back in Unit 1.